correct me if I'm wrong, but the first week, it was just a review of like quantitative data concepts, right? From your research course.
Yeah.
Yeah. Okay. So we don't need to go over that because it really has no bearing on this assignment whatsoever. And you guys already know all that stuff because you all kicked ass on the research thing.
Yay, it's finished.
I know. I'm so proud of you guys. No, seriously. So many people failed in my class, and I think everybody that did the tutoring passed, and some people got like really good marks. Like I'm impressed. It was pretty awesome. Okay, so you can see this, right?
Yes.
I kind of just want to give like 5 or 10 minutes just there were a couple more that wanted to do today. I don't want anyone to miss it. And then we'll start. Does anyone have any questions before we start?
Hey, Lauren, it's Christina. Quick question.
Yeah.
You know, you know how everyone's saying about the recording? Are the people, like, are we going to get a copy as well? Or
Yes, you can have a copy.
Oh, okay, perfect. Because I haven't actually started studying the stuff yet.
You know what, though? It's really not that bad, especially the first one.
Okay.
And yes, I'll send you the recording for sure. And I'll send you like I can send you these notes. I'm just like trusting you guys not to like spread them all around campus because like I work my ass off on all
this. Definitely.
Okay, so this is the meat right here. This and the next module is what we're going to use to do our assignment. So I just want to run through it really, really quickly. A lot of it is repeat. So you guys are going to be awesome at this. If you don't understand something here, seriously stop me and ask, because if you don't get this stuff, you're going to have a really hard time with the assignment. Okay?
What are we doing there, Laura?
What?
What are we, the stats module 2 notes, what are we doing there?
So
is that pertaining to the,
I'm going to go over the concepts that you need to understand in order to do the assignment.
Okay.
So like I was saying, if you don't understand something, make sure you ask, because when you get to doing the assignment, it's going to be really confusing. Like if you don't know how to tell if something is nominal, you're going to be in big trouble when you get there. Okay, so we know what descriptive statistics is. We don't need to go over that. Inferential statistics, you don't need to worry about for this assignment. That's going to be your next one, so leave that alone. We went over this like ad nauseum last semester, right? The categorical and continuous data. So the biggest thing with the categorical data is that whatever the thing that you're measuring, so if it's male, female, RPN, RN, or PCA, or NP, or whatever, you can only be in one category. That thing that you're measuring can only be in one category at a time. So like, what's your highest level of education? You can only be in one group. You have to choose one, okay? We went through all this before. These are just kind of the general rules of, you know, what's nominal. So that whole, I don't know if you guys remember last semester, like that whole nominal ordinal interval ratio thing. And I said, you're gonna understand this for stats. This is where it comes in. If you choose the wrong one at the beginning of the assignment, your whole assignment's messed up after that. You have to know these, right? So ordinal, we talked about. These are categories, right? They have no order to them. They're just, this number represents this number represents that. You move on to ordinal, you've got this number represents this number represents that, but it also goes in order, right? And so this is where our Likert scales fit, for example, age groups, and we'll look at that again. Hello?
Yes.
I'm just kidding. So you know, for example, if you assign a number to levels of education, so 1 is high school, 2 is college, 3 is university. You think, well, 1, 2, 3, those are equal increments, right? But it's actually the thing that you're measuring inside of those things. So you're measuring school, right? And those are not equal. High school's 4 years, college is 2 years maybe, and university is 4 years, right? So they're not equal things, so it has to be ordinal. The only way you can call something interval is if it's like the intervals between the numbers are equal, right? And I know this is review, but it really matters. So then you move on to the continuous levels of measure. Sorry guys, I didn't have time to go through and make it look pretty for you, which I usually do. These are really my messy notes. So we're interval. Again, you've got your continuous numeric order with equal distance between numbers. You wouldn't have any descriptors that go with each number. So you wouldn't have, like up here where you have 1 is 4, or 1 is poor, 2 is fair, blah, blah, blah. In the intervals, you have what you'll say 0 is nothing and 10, it's like a pain scale, right? 0 is nothing, 10 is, you know, I'm in labor or whatever. So I'm hoping you guys already have this, like you studied it like crazy last semester, so I'm not gonna like go crazy. The difference between the interval and the ratio is the presence of an absolute 0. So when you're measuring something, let's say temperature, for example, when you get to 0, is that 0 meaningful? Does that 0 mean there's none of the attribute that we're measuring? So there is no temperature. Well, no, it doesn't, because you can go below 0, right? Also, sometimes when you're measuring something on a scale from 1 to 10 that, I'm trying to think, like, I don't know, just something that okay, so happiness or something, right? On a scale of 0 to 10, maybe 0 doesn't mean the complete absence of happiness. Maybe it does. It depends on how it's worded, right? But when you get to something like weight or height, when you hit that 0, if somebody weighs 0, it's the absence of weight. That thing that you're measuring, that weight or height, it's not there anymore. 0 is meaningful. It means nothing. There's nothing there anymore. Those are the ways for me, quick, that I can tell, you know, split them up. Because your first question, that's all you have to do is decide what kind of variables, what data, what it is, sorry. So none of this matters. So when we're doing descriptive statistics, so we're not making any like prediction at all. We're just describing the statistics. So there's three kinds of those. I know you guys have gone over this, right? You have your frequency distribution, your measures of central tendency, and your measures of variability. You can use a frequency distribution for every kind of measure, whether it's it's nominal, ordinal, interval, or ratio. But your measures of central tendency and your measures of variability, which are your mean, median, mode, standard deviation, range, those you have to have interval or ratio data. You can't do math. You can't do math with nominal and ordinal data, right? There's no mean because the numbers have no meaning. They have no mathematical consequence at all. Elaine says, see, this is, do you guys listen to Elaine's recordings?
No,
Yes.
I was halfway through it.
Some of you do. Okay, so people who are in class probably don't get her recordings. I found them really helpful, to be honest. But anyway, she said if on the final exam, if you're given a situation and you're being asked what type of statistical test would you do, and you don't even understand that right now because you haven't done any tests. If you're deciding on central tendency, like you want to figure out central tendency or variability, and the data is nominal, you're going to get that wrong, right? You cannot do math. You can't do mean, median, mode, whatever with nominal ordinal data. Okay. Frequency distribution. This is pretty much the backbone of this entire stats course. You just need to understand the whole concept of the distribution of scores or distribution of weight or whatever it is that you're measuring. This is the most basic way to illustrate data. You're just tallying up how often a score or a number or whatever appears, okay? You can display it in a table. You can display it in a histogram. or a polygon, and we'll go over this stuff, right? So a table looks like this. We're going to learn how to make these super easy. Again, so because nominal and ordinal data is discrete, meaning it can only be, you can only be in one category or the other, when you make a graph or whatever, it has to have this space in between, like this. So it's a bar graph, not a histogram. Okay, a histogram is simply a bar graph with the lines touching. Like it's really, there you go. So again, you can do this for interval or ratio data. And it shows, you can kind of see it here. You can see this like pattern, right? Like this. So in this little drawing that I have, and I can zoom in a little, you know, 3 of the scores were 4, 2 of the scores were 2, like, you know, or these are the scores, sorry. 2 of the scores were 2, 4 of the scores were 3, whatever. And you can see this shape to it right there, which you guys know by now because you've done all the homework, is your normal distribution pattern, right? Like this bell curve. And your polygon is basically the same thing, except it's done in a line graph. And you can mix the two together. You can have this and then have a line to show a trend on it, or it's still a polygon. You don't need to worry about bimodal for this assignment, so we're gonna skip it. You might need to know that for the exam, but when we study for the exam, we'll go over it. Oh yeah, see? They drew the little thing. So, normal distribution. So theoretically, there is a perfect distribution. Now this is like, they've done a million different studies on a million different things, and what's happening is we're always getting this kind of bell curve that we looked at earlier, this thing right here. You're always kind of getting this bell curve over and over and over again, where everything is clustered around the mean or the median. And then, you know, we'll talk about skew and stuff later. We don't need to go through this. Okay, we'll talk about it now, apparently. So, you know, you've got the skew when it's skewed to one side or skewed to the other. So here's the thing. I got these mixed up over and over and over again. So every time I did an assignment, I pulled up these notes. And if something was skewed, I looked at it. I'm like, okay, the tail is pulled to the left. So it's less than the median and the mode, which means it's a negative skew. Like I had to kind of go through. And this might not make a whole lot of sense right now, but it will as you keep working with the numbers. Sorry, guys. But basically here, where you have your mean is here. Actually, if I get this. Okay, so here, where your mean is right here, okay? It's perfectly in the middle, right? You've got the exact same number on this side as you do on this side, right? It's not leaning one way or the other. This is a perfect frequency distribution. Over here, your mean is way over here, right? This is your average. And so you've got this tail, all of these scores that are higher, right? Than that makes sense? They're higher than the mean. So it's skewed, but the tail is less than the median and the mode. We're gonna go through this again. It's gonna make more sense. It's just, and then again, you have the opposite, which is the negative, or the negative skew, right? Oof, oh look, these are good. So here's your mean here, right? But because you have outliers, it pulls this distribution over, right? And so now your median is actually more in the middle than your mean. Does that make sense to you guys?
Yeah.
Does it? Okay, because it's actually really, people had a really hard time with this last year. I can't see, if you guys are trying to use the chat function, I can't see it. So you have to actually talk, I'm sorry. And then, so when you get to a point in your assignment where you're going to have to describe the, the frequency distribution, blah, blah, you're going to have to say it's skewed negatively, it's skewed positively, blah, blah, blah. So if you get the numbers out and your mean is 52 and your median is 40, then you've got it's positively skewed. Okay. And again, you don't have to memorize this or like you can just keep coming back to it when you need to use it. Worry about memorizing it for the final. And kurtosis, easy peasy. I don't even think you need to put this in your paper, but if you want some bonus marks, maybe, you see the different shape, right? If it's shaped like this, it's leptokurtic. This is the regular distribution, and then your platykurtic here. No big deal. None of that is like as complicated as it sounds. And you guys know your measures of central tendency, mean, median, mode. You can only do it with interval data. Does anybody have a hard time with the central tendency? Like understanding it? No?
Sorry, I haven't even started.
Yeah, sorry, me too.
Okay, no, that's good. Okay, I'll start over. I'll do this then, okay? So again, remember we talked up here, you guys are so cute. We talked up here. It's okay. A lot of people, last year I was like, so I'm basically teaching you guys the course. And they were like, yeah, it's fun.
That's exactly it.
All right, we'll go. That's okay. So remember we talked up here. I have the worst pen thing over here. So these are our 3 types of descriptive statistics, right? You have your frequency distribution, your measures of central tendency, and your measures of variability. I'll just take those off later. So let's go through the measures of central tendency first. And again, this stuff that we just talked about, if you haven't heard it before, that was probably like, don't worry about it. It's going to make sense as we go through this stuff, okay? Blah, blah, blah. Let's find that again. Okay, so our measures of central tendency, there are 3 of them, right? You've got your mean, your median, and your mode. My son was actually doing this for math class last year, and he was super impressed because I was doing this course at the same time, and he was like, how do you know this? So that's not how he talks. So the mean is just your average, okay? So you've got a frequency distribution chart, and let's say you're doing something like age. Let's keep it really simple. We're doing age. We have 100 people, and the average age of the group is 52 years old. That's your mean. That's how easy it is, okay? There's nothing complicated or remotely difficult about that. You don't need to know any of this math, okay? Don't worry about it. Even these symbols from, they never came up again after. They were in the slides, they never came up, but this is the score. So for example, if you have a chart and you've got like a bunch of scores, right? You know, X equals, like, say you're talking about this score right here, you're gonna say X, whoop. Okay, for some reason it doesn't like me right now. No. Okay, whatever. You're gonna say X equals whatever this is, and then N equals the sample size. The little X with the line over it is the mean of the entire sample. So it's very, you know, the universal mean, which we'll talk about later, and the sum. Honestly, guys, these never came up. You can look at them and make sure you kind of have an idea, but I wouldn't worry about them. Okay, so the first measure of central tendency is mean. The second is median, okay? Now what this is the exact middle score, okay? So let's say we're doing age again. Oh, actually, let's do whatever this example is right here. It's already written down. So at whatever point, exactly 50% of the scores are below and 50% of the scores are above, that's your median. So you literally so you count scores. So, okay, you have to take it one step at a time, I guess. You put the scores in order. So you have a score of 16, 1 of 16, 1 of 17, 1 of 18, 1 of 19, 1 of 20, blah, blah, and so on. Okay, you put them in order. And then what you do is you find the middle. So, you know, you just do this. Blah, blah. I know this is like babyish, but it helps. Right? There, there, there. You've got your median. Now, of course, this example would be normally there would, for the first example, they would be nice and give you one that's right in the middle, but whatever. They gave you, if they're split like this, you just split the difference between these two numbers. So the median here would be 22.5. I hope that makes sense. So if you have a large number of numbers, let's say you have like 500 scores that you have to do. And you can't really sit down and put them all in order like this. There's this little way that you can do it. This little, the total number of numbers plus 1 divided by 2. Then you can kind of count to that point in the sequence. You, again, will probably not need to use this. Okay, so don't worry about that. Just understand this, how to calculate the median and what that median is, because the median is actually really important when, for example, you have, let's say you have, you know, the age again, you have 100 people, and if the mean is 52, the average is 52, but let's just say, for example, you have one person in the study who's 103 years old and you have another person who's 98. They're gonna pull that median, that mean. Do you know what I mean? It's like when we do an exam and somebody gets a 95, right? And they pull the whole class average up. It's the same thing. It's an outlier. It's an extreme score. This 98-year-old man and 103-year-old woman or whatever, they're pulling that up. So your mean up here isn't necessarily the best example of the average. It's not as meaningful, I guess. So in that case, you would switch over and you would use the median instead. The median makes more sense as your measurement of central tendency at that point. I hope that makes sense, but you're going to do it in your assignment, so it'll make sense.
So Lauren, if there's extreme scores, we shouldn't use the mean.
If there's extreme scores, you always use the median as your measure of central tendency. Yeah.
So we should use the median if there's extreme numbers. Okay.
And we're gonna go over that in the assignment. It's
okay.
Gonna show up in the assignment, I think. But yes, the median, you can see here, it's not affected by those extreme scores. See, and here, use it when you have. It's all written here, and you guys can have this paper when I'm done. I'll take all the lines and stuff off it for you. Let me see if asked which. Yeah. So again, if you get asked in an exam, you know, why would you use the median instead of the mean? It's because the median isn't influenced by any outliers. The mean is the most accurate, but in a case where there are outliers, the median would be the best choice because it's not affected. And you're actually, this sentence right here is probably going to be written, hopefully not exactly in my words, in your assignment at some point, because this does happen, I'm pretty sure. Okay, so your third measure of central tendency is your mode. And all that is the value or the score or the number in your whatever that shows up the most often in your frequency, your distribution. So again, let's look at this right here. You know, I don't see one. Let's say 23, I think. 23 shows up 4 times. 4 times, that's probably your mode. Right there. I don't want to look too carefully, but it's just the number that shows up the most often. That's it. It's not anything too special. All of your stuff is going to be unimodal, so I wouldn't worry about this bimodal or no modal. Maybe just we'll worry about it for the exam, but not for the assignment. Okay, so she was just explaining what the first assignment was going to look like, which we'll go over, and blah, blah, blah. Okay, so really quick, we're going to do the second week. I just need to find it. There it is. Okay. So again, don't worry about that. So now, remember I said there are three, in descriptive statistics, there are three kind of things that we use to describe the statistics. There's your frequency distribution, your measures of central tendency, and your measures of variability, okay? So we talked about the measures of central tendency, which are mean, median, and mode. We talked a little bit about the frequency distribution, which, trust me, you're gonna get eventually, because it's just, it's the entire backbone of what we're doing. And then this week here, they talked about measures of variability. Let me put my pencil on again. So the variability is measuring how much variety. It's about the magnitude. So for an age on a scale in years, right? We want to know how spread out is the data, right? What's the variety of the age? What's the spread? So remember earlier I was saying, like, are you heading out? Sorry guys, one of my friends was here hanging out before, you know, my life is chaotic. So, but anyway, she already understands all this probably better than I do. So again, if we're looking at that string of ages, right? We have 100 people. And remember I said, well, we have a 98-year-old and a 103-year-old that's pulling that average up. These measures of variability will kind of identify some of that for you. They'll say, okay, but your average is 52 or your mean is 52, but your spread is age 40 to age 103, right? And so right there you can see that you have to have outliers. And we'll go over this again, but that's kind of the importance of the whole variability. Basically, your measures of variability describe how all of that information, all those scores that you have, how they're distributed. Do they look like this, or do they have a curve to them, or whatever? And then you also want to know, you want to take one score. So you guys, you know, you do an exam, you've got 75% on the exam. You want to know where that sits, you know, like half the class got higher, half the class got lower, or what have you, right? So you're going to use these three measures of variability. So remember, there's three measures of central tendency, there's three measures of variability. Range is basically like the range. It's the difference between the lowest and the highest scores. So again, we have that age range from 40 to 103, it's going to be 63, right? The difference between 40 and 103, which I hope is 63. My math skills are not great. So when whenever you express range, you always say the range was 63 with the lowest number being 40 and the highest number being 103. Right? Because it matters what those numbers are. You can't just say the range is this. But the problem with the range, sorry, whoever's got, can you guys mute yourself if you're like just fiddling with papers and stuff, if you don't mind? Thank you. So these range, right? It describes the spread, but you're only measuring the extreme low and the extreme high.
Hi, how are you?
Hello? So this is actually not a really great measure of variability, but it is important. Did somebody just log in?
I did, halfway. It's Betty.
That's okay. Hi, Betty. We're just going over standard. We're going to start going over standard deviation. I don't know if you can put your phone on mute when you're not talking. It's really helpful just because we can hear like everything in the background. If not,
I'm so sorry.
It's okay. It's okay. Just try not to move.
Okay, I'm going to put it on mute just now. Sorry. Okay. Thanks so much.
No problem. So our three measures of variability: range, standard deviation, and variance. We talked about range, very simple. Standard deviation. For some reason, this is very confusing, and it's actually not, you guys. Once you get it, it's just like, it's really easy. This is the most commonly used and the most important measure of variability. It uses the mean as a reference point and measures the distance between each score and the mean. So it's measuring The standard deviation tells you the average distance of those scores from the mean, okay? So we have that, you know, that spread. It's telling, and here's your mean right here. Oh, for Pete's sake. I don't know why that's happening. It hates me. Your mean is in the middle. It's telling you, on average, how far are the scores from that mean, okay? So your standard deviation is really, really, really important in order to identify outliers. Because if the average score, let's take that age thing again, okay? So you've got a range of 40 to, what did I say, 103. Your average is 52, okay? If your average score is 3 years or three years below 52 or above 52, right? Actually, let's say 10 years, just so that I, you know, from 52, what's 10 years on either side? 62 and 42, right? So if you're outside of that, right? You're outside of one standard deviation away from the mean. So in our little thing, we still have a score of 42, right? Sorry, of 40. So we have to do another standard deviation. We have to move again, right? And we're going to do this like 4 times. So I know it's a lot at first, but it will make more sense. When you move again, then that 40 is caught in that standard deviation. So it's not an outlier. And I'll show you, we're going to talk about it more here. This is good because it's got a good drawing for you to kind of understand. Woo! Okay. So the technical definition here, oops, sorry, is the amount that any one score varies around the mean. Okay, and again, it's the average distance from the mean. Okay. In a perfect bell curve, and this is really, really important to understand, okay? Don't worry about these numbers down here for now, for a minute. In a perfect bell curve, if this is your mean right here, you're going to have, see how this beautiful curve is exactly symmetrical, right? You're going to have, this is, okay, so this is your first, just so we're clear, this would be your first standard deviation, your second standard deviation, your third standard deviation on this side. This would be your first standard deviation, second, and third on this side, because we're just talking about how far it is from the mean. It can be far on this side, or it can be far on this side, okay? So in a perfect frequency distribution, you will have 34% within one standard deviation of the mean on this, on the positive side, depending on what your scores are, and 34% within one standard deviation of the mean on the negative side. I like to think of it personally, it just helps me to think of it as you will have, in a perfect frequency distribution, sorry, it's really hard to write with this, you will have 68% will be within one standard deviation. This and this is one standard deviation on, so one standard deviation on this side, one standard deviation on this side, you have 68% in there, okay? Within 2 standard deviations, you're going to have 28%. You can see the 14 on each side, right? And within 3, usually you're not going to worry about, 4, whatever. You're going to have the other 5%. So this, so we have 68 and we have 28, and for 68, I don't know. The point is, when you look at this whole thing, so within 2 standard deviations, okay? You look at all of this here, all of it. This is really important. This is what's going to help you. It's way easier to think of it this way. 95% of scores are going to be within 2 standard deviations of the mean, okay? We're going to go over this like a million times, but what you have left out here on either side, because well, we'll talk about that later, is these are outliers. So you're generally going to have about, in a perfect standard deviation, you're going to have 5%. I don't know why this is labeled wrong. 2.5 on this end and 2.5 on this end of
I'm good. How are you?
outliers.
Studying? Yeah.
Hey, can whoever's talking just mute the phone? Thank you.
That doesn't look like anything I want to know.
Yeah, we don't want to do it either. Okay. So I know it looks complicated, guys, but it really, really isn't. So let's say we want to calculate, actually, let's just really quickly go over variance before we go more into the standard deviation. The variance is the distance. You're not going to use this for this assignment, so don't worry. It's going to be the next one, but just to know, it's the different distance between each score and the mean squared. So basically, it's the standard deviation squared. And that's because you need it to be squared to do calculations when you're doing your ANOVA test and your later. But don't worry about it for now, okay? And again, we'll go over it when we study. I think I kind of said all of this just now. Yes. We'll talk about that later. Don't worry about the degrees of freedom. Okay, your Z score. I find the way they teach this to be really confusing. So it basically is what I was just telling you. You have a thing with a bunch of doohickeys all over, whatever, and you've got your curve that looks like this. You know that your mean is here. You know your first standard deviation is here, your second standard deviation is here. So your Z score is whatever score you're looking at, where it is on this. So if it's here, then we'd have to have numbers labeled down here in order to get the Z score, but that Z score is labeled. And I know that that's really confusing now, but it will make sense when we do the assignment. And again, I don't think you need to even use the phrase Z score in the assignment. All you need to understand is this outside of the standard deviation, 2 standard deviations, or is it inside? And that's it. Again, the point is you want to identify the location of the score within that distribution. So you want to know, for example, again, I think I said this earlier, you got a 76 on the test. Oh, let me just clear some of this off so we can actually see what we're doing. Okay, you got a 76 on the test. Standard deviation is 3. This doesn't say the mean, but the mean is 70 here. Okay, your standard deviation is 3. Oh, look, she drew it down here. Perfect. Okay, here's your mark here, okay? And you want to know where do you stand in reference to the rest of this class. This is your, okay, so, and then the average or the mean was 70. The standard deviation is 3. So 1 standard deviation would be 70 plus 3, which would be 73. 2 standard deviations would be 70 plus 3 plus another standard deviation, which is another 3, which would be 76. So you're almost an outlier. You kicked butt, because here's the thing. You know that 95% of the class in a normal standard deviation is back here, right? Unless you've got some asshole who's got a 98, right? If it's a normal distribution curve, you can really see, okay, I did really well on this test, even though like, oh man, I don't like getting a 76, but look at it, 95% of the people got lower than that, right? But let's take the same story and you got a 76, here's your score. Now, let's say, again, the class average was 70, but this time the standard deviation is 12. Oh, I hate this. I gotta get a better pen. Okay. So now we go 70 plus 12 is 82. And we don't even have to calculate the next standard deviation. Probably because I can't, stupid math, I don't care. And so, so you see here that your mark is actually falling right here within that first standard deviation. And remember I said 68% of people will fall here, right? And you can actually get, you know, your score here, this is your score. You can see where you stand in the class because of the standard deviation. Does that make sense? God help us. Is everybody getting that? Because
Lauren,
yes.
you know how you were talking about the standard, so you know your first drawing where you sort of shaded in the first deviation on the left and the right side?
Yep.
So in this one you said the first standard deviation from the 70 to the 73 is 3.
Yep.
So
what would it be on this side then?
it would be 3 the same?
Yep.
Or
yep. So over here it would be 67.
okay, so whatever it is on one side is the same because it's the bell curve, so it's going to be the same on the other side.
Because it's a perfect curve. And always whenever you're talking about standard deviations, you're always going, whatever that standard deviation is, and it's usually not a round number, by the way, it's usually like 3.5678 or whatever. You have to do it both ways. So one standard deviation this way, one standard deviation this way, and then 2. And again, so let's say you got 6, so say you got 60, right? So 67 is one standard deviation, which makes 64 2 standard deviations, which means you're an outlier. You're well below. 95% of the class got above 64. You know what I'm saying?
So regardless of what the data is, it's always 95% is within the first 2 deviations, is what you're saying?
Yes.
Okay, so it doesn't matter what the data is.
It doesn't matter what the data is. It can change. So if you have a skewed that goes like this,
Yeah, okay, got it.
mean is here, then yeah, it kind of messes up your standard deviation, right? Because you've got.
Got it, okay.
Right?
That makes sense.
I don't think this comes up in this course, so I wouldn't worry about it.
Okay.
But yes, that, and honestly, if you can grasp the whole idea that this 95% is within those first 2 standard deviations on either side, if you can get that, when you go to do your t-test and you're a NOVA and all of that in your next assignment, it's going to be really, really helpful to get this. This is, it's like I said, it's like the backbone of everything that you're going to do from here on.
Okay.
And is that okay?
Yeah, that's great. Yeah.
Good. Okay. Oh, look, here, I wrote it down. Here's a little picture of what I've been telling you. So you can see it here. There's your mean. See, the 95 is within 2 standard deviations. 99% is within 3. And there's, so really, we only care what's outside of 2 standard deviations. We're just looking, is there an outlier? We don't, I mean, 3 standard deviations is great and whatever, but that's not going to be important for what we're doing this semester. You're just looking for, is anything outside of 2 standard deviations, in which case all you're worrying about is that 2.5 above and that 2.5 below, even though, yes, some of it is past 3. Doesn't really matter. You're just looking for what's outside of the standard deviation. Look at that. That's it. Okay.